for humanity, it will be the same for 1989. Too many things happened around that year, and the most symbolic is the fall of the Berlin Wall, a wall that falls precisely as a universal symbol, a world that opens up, that no longer has borders. Yes, for over a decade we all thought that we would finally be pacified, united, found again under a single flag, that of humanity. And it is precisely based on this collective dream that I will speak of my thesis. The era that has begun and that we are living is based on the internet, a technology that has turned our lives upside down, changing them forever, and has completely overturned the way we approach knowledge and technology. I won't digress much on the history of the internet, the web, the global village, Wikipedia, forums, digital activities, and social media, artificial intelligence. You've heard these things many times, and we all know them well. What everyone ignores, however, or what in a certain sense goes unnoticed, is how open source was precisely at the basis of this revolution. How open source is the backbone of the technologies that have enabled this epochal change. And I wonder if in 500 years, in history books, they will talk about Google, or about open source as a movement, as a phenomenon, as a shocking event that has unleashed and triggered gigantic social and cultural sparks and effects. Well, it doesn't seem to me that opening a history book, I find written in the first industrial revolution the name of the company that designed steam locomotives. But instead I find who invented them. And I don't seem to find even the names of the oil companies, the Seven Sisters, that gave rise to the oil economy in the 19th century. Rather, I find oil itself, how it is exploited, where it comes from, its chemical composition, where the major deposits are found, how it spread. Here we are, welcome to the open era, or more precisely to the digital era, where open source rules and represents its infrastructure. It would be more appropriate to talk about open source rather than Steve Jobs, with all due respect for Steve Jobs, because in 500 years, it won't be him dominating the first page reserved for our time. HTTP, times without thinking too much about it. Yet it's precisely from there that everything passes. HTTP stands for Hypertext Transfer Protocol, and it's the beating heart of the web. When we type an address in the browser, when we click on a link, when we load a page, behind every action there's HTTP working in silence. It was invented in 1991 by Tim Berners-Lee at CERN, the same scientist who created the World Wide Web. HTTP is not software, but a communication protocol, a standard language with which computers talk to each other, exchange pages, images, content. Its strength, it's open. HTTP is publicly documented, it hasn't been patented, and anyone can use it or implement it. This total openness allowed the web to explode. No company had to ask for permissions or pay rights to use the internet. It was enough to read the specifications, write code, and connect. This is how browsers, servers, search engines, sites of all kinds were born. HTTP is the invisible infrastructure of our era. It's the one that every second circulates billions of web pages. But more than anything else, it's one of the first and most powerful examples of the power of open source. Because behind the illusion of clicking on a link, behind the fluidity of a scroll, there's a silent revolution, a free, public technology built for everyone. And have you ever wondered why, when you look at a web address, HTTPS often appears and not just HTTP? Well, that too is the fruit of open source. That final S stands for secure. It means that the communication between you and the site you're visiting is encrypted, protected. No one can intercept what you're doing. Neither your provider, nor a hacker on the bar's Wi-Fi network, nor some overly curious government. This security is made possible thanks to a system called SSL, or better in its modern evolution, TLS, Transport Layer Security. SSL, Secure Sockets Layer, was born in the 90s, initially developed by Netscape, but today the most used implementations are open source. OpenSSL, LibreSSL, BoringSSL. They are free, public libraries, constantly improved by thousands of developers around the world. When you visit an HTTPS site, it's very likely that behind it there's OpenSSL, an open source software that encrypts your data and guarantees the security of connections. And do you know what's even more interesting? Today, anyone can obtain a free SSL certificate thanks to projects like Let's Encrypt, an open-source initiative supported by large organizations that has made the spread of HTTPS throughout the web possible. Once you had to pay and rely on a commercial CA. Now, just a command, and it's done. Thanks to open source, security has become a right, not a luxury. In short, even here, behind the simple facade of one more letter in the address, a profound revolution is hidden. A revolution that has no masters, but a community. Let's dig even deeper. Let's go right inside the infrastructure that brings the internet to your home. Many of the home and business routers we use every day run on firmware based on Linux or on open-source operating systems. We're talking about software like OpenWRT, DDWRT, pfSense, OPNsense, community projects that have transformed the way we manage networks, firewalls, VPN connections, data traffic. They have brought innovation, security, and freedom to a world that was previously completely closed and dominated by proprietary firmware, often full of bugs and unresolved security flaws. With these open-source systems, you can control every single packet that passes through your network, create rules, block advertising directly from the router, segment devices, manage quality of service, protect yourself with advanced firewalls. Functions that were once reserved for expensive professional equipment, now within everyone's reach, for free. And let's not forget that many industrial network devices, even in critical environments, are based on open-source technologies. Because open source is not only free, but is also solid, tested, reliable, verifiable. Here you see how the infrastructure of the modern world is built. Layer after layer, protocol after protocol, device after device, and it's open source that connects everything. It's not a decoration, it's the backbone of the digital era. And now stop for a moment. Have you ever wondered where all this is physically located? Where does the internet live? Where does all this magic end? Have you ever really tried to imagine it? I don't think there's a scientific method to count all the pages existing on the web. We are literally immersed in an ocean of data, and not even spending a whole lifetime browsing would we be able to discover it all. How beautiful this immensity, this chaos without borders, this infinite exploration. But at the end of the rainbow, there's no magic cloud, there's a data center. Actually, millions of data centers scattered all over the planet. Real, physical places, full of cables, fans, disks, electric current, and Linux. Yes, exactly, Linux. Always him, always open source. And it's not a slogan, it's reality. The servers that host sites, apps, banks, governments, artificial intelligences, satellite systems, and even this video you're watching, almost all run on Linux. Ubuntu Server, Debian, Red Hat, Alma Linux. Different names, same soul. Open, accessible, shared. So yes, every time you hear about cloud, neural networks, artificial intelligence, blockchain, streaming, remember this: there would be nothing without Linux. There would be nothing without open source. And we keep repeating it, yes, but not because we're obsessed, because it's the most ignored truth of our time. Have you ever wondered how all this system works? Who controls it? How is it managed? How does it integrate and interconnect? The internet is not an entity suspended in the void or an abstract concept. It's a physical immense network that connects autonomous networks belonging to research centers, providers, companies, schools, public entities. It is in essence a network of networks, a distributed ecosystem where each node speaks the same language thanks to common protocols like TCP/IP. At the center of all this, there's a supporting structure, often invisible to the eyes of those who use it every day, the internet backbone. This is where the so-called Tier 1 ISPs operate. The large global operators like AT&T, Cogent, Tata Communications, Deutsche Telekom, Verizon, NTT. They are the ones who own the main infrastructures. The ultra-high-capacity fiber optic cables that cross oceans and continents and interconnect with each other in the large neutral hubs called Internet Exchange Points, or IXP. It's there that the exchange of traffic between different networks takes place, in a neutral and efficient way. Alongside these giants, there are Tier 2 and Tier 3 ISPs, regional and local operators who buy access from Tier 1 to reach the rest of the network. It's a functional hierarchy that is articulated in 3 levels: the core layer, that is the global backbone, then the distribution layer, which aggregates traffic at a regional level, and finally the access layer, which connects us at home or at work. This multi-level model guarantees extraordinary resilience. If a node collapses, traffic can be redirected to alternative paths in real time. But the question arises spontaneously. Who controls all this? Who governs the internet? The most honest answer is no one in an absolute way, but many in a collaborative way. The internet is not controlled by a single central authority. It's a decentralized system, governed by a balance between large infrastructural operators, technical bodies, and communities. Tier 1s manage the physical structure, cables, main routers. But the rules that allow everything to work are established by the IETF, the Internet Engineering Task Force, which develops and maintains fundamental protocols like TCP/IP, DNS, and BGP. Overseeing the assignment of domain names, IP addresses, and unique identifiers are ICANN and IANA, which operate at a global level. Alongside them, organizations like ISOC, Internet Society, and the W3C defend open standards and promote the philosophy of open source. Governments obviously exercise an important influence on aspects like privacy, security, and network neutrality through bodies like the FCC in the United States or the ITU at an international level. And then there are users, local communities, independent projects that build infrastructures from the bottom, like Giphy.net in Spain, which demonstrate how an alternative, distributed, free internet is possible. This is the internet, a collective creature, physical, fragile, and powerful. A human construction that has been able to grow without a center, without a master, but not without rules. And in the heart of this global infrastructure, the one managed by the network giants, the Tier 1 ISPs, open source is present, often silently. Routing, monitoring, automation, and management systems are based on Linux, on projects like Bird, FR Routing, Prometheus. Sure, the hardware often remains closed and the highest-end switches still speak proprietary languages. But the brain that commands them, the one that decides where traffic goes, how it's analyzed, measured, optimized, speaks open source. Even in the intermediate level of the network, that of regional networks that aggregate traffic between the large backbones and end users, open source plays a fundamental role. Many Tier 2 operators use open source software like Bird or FR Routing to manage the BGP protocol, the one that decides how to route packets through networks. They are the same tools used in the main European Internet exchange points, and this makes them particularly widespread and reliable in regional peering. Not only, many devices used by these providers, especially in low-cost contexts or in emerging regions, work with firmware based on Linux. There are also regional ISPs that manage the entire infrastructure with Linux and open software for every function, from DHCP to NAT, from firewall to VPN, up to captive portals for managing public access. And to be able to control all this efficiently and on a large scale, tools like Ansible, Zabbix, Grafana, Prometheus, LibreNMS, Netbox, Nagios come into play. All open source and all indispensable for automating, monitoring, optimizing network performance. Without these tools, operating costs would be unsustainable for many Tier 2s. Even the management of fundamental services like DNS is often based on open source software. Resolvers like Unbound, Bind, or Not DNS are widely used, as well as FreeRadius, DNS Mask, and other systems for authentication, dynamic assignment of IP addresses, or access control. In short, even if we don't see it, under the surface of every regional network beats an open source heart. There is then another fundamental actor in the Internet architecture, the IETF, the Internet Engineering Task Force. It's an international organization that doesn't write code, but something even more important, it writes the rules. It's the IETF that defines the protocols that make everything work, from TCP/IP that allows computers to communicate, to DNS that translates names into IP addresses, to BGP that routes traffic between networks, up to HTTPS that makes our browsing secure. All these protocols are open standards, freely consultable, published in documents called RFC, Request for Comments. No one has to pay anything to implement them. No one has to ask permission. And here, open source comes into play once again. Because while the IETF writes the grammar, it's the open source world that puts it into practice. The first TCP/IP stacks, DNS resolvers, SMTP and HTTP servers, BGP implementations, were born and grew as free software, and they are the ones we still use today. Let's think of BIN, the most widespread DNS server, or ISE DHCP, the Quagga daemon, today FR routing, or the 1,000 tools that implement the protocols defined by the IETF, all open source. It's a virtuous ecosystem in which theory and practice feed each other. The IETF guarantees that knowledge is free. Open source transforms it into accessible technology. And so, even if the IETF doesn't define itself as an open source project, it's thanks to its open standards that open source has been able to become the backbone of the web. But it's not over here. Because inside this great global infrastructure, founded on open source, today run the most advanced and decisive technologies of our time: the cloud, containers, artificial intelligence. And here too, the heart beats open source. We're no longer talking only about protocols, servers, and routers, but about a new level of digital evolution, an abstract, scalable, dynamic, powerful level. And here too, dominating is the same spirit: open code, sharing, global collaboration. The cloud, for example. We all use it, maybe without knowing it. Google Drive, Dropbox, Amazon, Netflix, YouTube. Every modern app is based on cloud infrastructures. But the very concept of cloud computing has been shaped by open source. Data centers run on Linux systems. Virtualized architectures are managed with KVM, QEMU, libvirt, Proxmox. The most powerful cloud platforms are built with tools like OpenStack, Ceph, Kubernetes, Terraform, Ansible, all open source software. Even the big tech companies, Amazon, Google, Microsoft, that offer commercial cloud services are internally based on open components. They use them, extend them, customize them, often without ever declaring it openly. Then there are containers, a revolutionary concept which has changed the way applications are distributed in the world. Containers allow you to isolate, package, move, replicate software efficiently and modularly. And everything starts with Docker, an open source project that made accessible a technology born in Unix laboratories. Docker then opened the way to Kubernetes, the most powerful container orchestration system in the world, initially developed by Google and today maintained by an open foundation, the Cloud Native Computing Foundation. Kubernetes is not just open source. It's a manifesto of a new way of thinking about software, made of microservices, modularity, abstraction, and then there's artificial intelligence. Here too, the dominant narrative tells us about large companies, closed models, paid APIs. But reality is very different. The most used libraries for machine learning are open source. TensorFlow, created by Google. PyTorch, created by Facebook. Scikit-learn, Keras, Hugging Face Transformers, all open. The infrastructures for training and distributing models, Jupyter Notebook, Ray, MLflow, are also open source. And more initiatives are being born to create open, powerful, and transparent models like Mistral, Falcon, OpenLlama, OpenAI's Whisper, or Stable Diffusion for image generation. Even code models like CodeLlama, StarCoder, or Phi2 are open. And when we talk about ethics, transparency, algorithmic justice, it's always open source that offers the only real concrete alternative. But it's not just a matter of tools. Even the programming languages on which all this world is built are open source. Python, the language of AI, Go, the language of containers, Rust, the language of security, JavaScript, the language of the web, all born and grown in the culture of sharing, all supported by communities, not by patents. What is happening, therefore, is clear. The open source revolution has not stopped at infrastructure. It's growing upward toward the most complex, most strategic, most decisive technologies of our time. And this growth is organic, natural, almost inevitable. Because when a technology needs to scale, adapt, innovate, evolve, only open source has the flexibility, strength, and collective intelligence to do it. When transparency, security, auditability are needed, only open source can offer trust. And when looking for a common base to build the future, you don't rely on a company, you rely on an ecosystem. And that ecosystem, today more than ever, is open source. That's why, if in 500 years someone stops to reflect on this era of ours, on what made it great, on what really transformed it, they won't remember only the names of companies, founders, iconic products. I hope and believe that they will talk mainly about open source, because it was him, the silent engine, the current that powered everything, the hidden value that allowed the explosion of the web, the cloud, artificial intelligence, shared knowledge. Open source is not just code, it's the invisible base on which we are building our lives. It's what allows us to communicate, work, learn, create, collaborate, often without even realizing it. Yet it's there, under everything, in servers, routers, protocols, languages, AI models. It doesn't shout. It doesn't show off. But without it, none of this would exist. This is my thesis, that the revolution we are living, the digital one, the cognitive one, the global one, originated precisely there, in the decision to share knowledge, to open the code, to trust collective intelligence. A simple idea, but powerful, an idea born from below. But that has lifted the world.